In this video, I'm going to show you how you can create your own LLM classification system in 5 simple steps. Now, if you don't know who I am, my name is Ebbelaar. I'm the founder of Datalumina, and I've been building custom data and AI solutions for the past 5 years. And next to that, I create educational videos like this to help you do the same and ultimately get started with freelancing. So let's dive in. All right, so how to create an LLM classification system in 5 steps. Now, for context, in this video, I am going to walk you through some examples of classifying text, more specifically tickets from a customer care ticketing system that we are going to emulate. So the goal is, given these tickets, to put a label on them, to categorize them, and later, as you will see, also add other metadata and information that is relevant to the system. Now, that said, while we are going to use text right now, with the capabilities of OpenAI and other models, you can also apply these same principles to classifying images or classifying audio. You can almost classify any data at this point using the approach and the techniques that I will share in this video. And to put this into perspective, this used to be a pretty hard problem to solve, classification in general. One of the, I think, most well-known examples is your email inbox, where in the background there's always running a filter of spam and no spam to route emails. And you used to be a machine learning engineer to create classification systems in order to do it really well. But now everyone, including you, can build systems like this in a few lines of code. So that's what I'm going to share with you today. So let's start with the 2 tickets that we have over here. We will also be using the OpenAI library for this, and we will do this example in Python, but you can do this with other language models as well, and you can also use almost any programming language to do this. So let's start up an interactive Python session over here and load the tickets here into place. Now, what I'm going to do is I'm going to show you first an example of how you would maybe tackle this problem. So we use OpenAI, and I'm assuming here that you're already familiar with OpenAI chat completions. So I'm going to skip over that a little bit here and just assume that we have a system prompt over here and it says classify the following customer support ticket into a category. So we leave it very open, and then as for the role, we insert the ticket text over here as the content. So we create this little function. We can run that over here on the right and then print that. And what we will get is category. It will say order issue. The thing that you can immediately see over here is that even though we can really improve this with prompting techniques, etc., but I just want to show you a plain example. This, from a system design perspective, is not ideal because we just ask it to classify the ticket into a category. We have no idea what all the potential categories could be. And also we see that it returns a response with category and then order issue. So if we, for example, would now take this and would put this into a system, we would first have to parse it, right? We have to get rid of the category because we only want order issue. That's the value that we want, for example, to put in the database. So right now it's still the same, but let's say we change the temperature over here, change the temperature to 1, run that one more time. And here you can see we have a completely different response. Order issue, incorrect item received. So when we just use this approach, there are a couple of drawbacks. So no structured output, making it difficult to really integrate into automated systems. Also no validation, leading to inconsistent categorization. We have limited information extracted. We only have the category. We're also missing important details. So we would maybe have to increase the prompt or do multiple calls to the large language models. There's also no confidence score, making it hard to flag uncertain classification for human review. So there are a lot of things that we can improve. So let's continue with that and get into really step 1. And that is to get clear on your objective. So pretty simple. You can even do this without the coding, but from a system design perspective, it's really important to think about your classification problem and think about where it fits into the business context, and also what other type of values or metadata or keywords you potentially want to extract from the data to overall improve the system. So for this classification problem, I've identified the following objectives. So we want the category and we want it to be accurate. We want to also assess the urgency and the sentiment of a ticket. We want to extract key information for quick resolution. And also we want the system to provide a confidence score to flag uncertain cases for human review. So that's the objective. Then also let's consider the business impact. So why is this relevant to implement? Why is this relevant to understand? We want to reduce the average response time by routing tickets to the right department, improve customer satisfaction by prioritizing urgent and negative sentiment tickets. We want to increase the efficiency by providing agents already with the key information up front. And we want to optimize workforce allocation by automating routine classifications. So that's the first step. But now let's get into the second step, which is a little bit more tactical, and that is using the instructor library. So let me make sure we import it over here as well. You can do a simple pip install to get the library, and this is literally my secret weapon to build reliable large language models application that can make it to production. So if you're new to the instructor library, I highly recommend checking out the website, the docs. It's available in different languages, and in essence, Instructor makes it easy to get structured data like JSON from large language models. And you can see some examples over here, but we are going to use data models, and more specifically Pydantic data models, to really first get clear on our objectives that we have identified, and then also make sure we put validation in place using the instructor library to really ensure that our system is robust. So it's really easy to get started with Instructor because we can just patch the OpenAI client with this simple example over here. And now we have a client that is instructor ready, and we can provide it with response models. So before we can do that, we first have to define those models. So that's going to be step 3. So let's now get into that. All right, so what the following code will do is it will define structured data models for the classification and also for the sentiment and the urgency. Now, if you're new to Python's data models or Pydantic, this can be a little bit confusing in the beginning maybe. So I'll give a general overview, but if you're completely new, I highly recommend to just look further into the Pydantic library. But what we're going to do is we're going to use a combination of enums, so enumerations, and a Pydantic model that's inherited from a base model. So let's first look at the categories. And what an enum essentially allows you to do is, let me make sure to run this one more time, make sure we have everything in memory, and let's look at the ticket category first. What we can do is we can first tackle the problem of, okay, what are the predefined categories that our system can accept? And if we now look at that, and once we have defined that ticket category, we can run that and we can see if we put in order issue, we correctly get the ticket category model back of type order issue. So that works fine. But now if we say, for example, general, it will hit us with a value error because general is not a valid ticket category. And what this allows us to do is really get clear on what does our system accept, and if OpenAI or any other language model now is going to get creative generating other types of categories, our system will return a value error. So that's how the enumerations work. And we can do the same for sentiment. We can do the same for ticket urgency. So these are just some examples. So those are the enums. So make sure we have those in memory. Now let's look at the Pydantic model over here. And you can see that this is a Pydantic model because we plug in the base model here that we import from Pydantic. And because of this, we can leverage all of the powerful data validation features that are part of the Pydantic library. So what we can now do is we can define a data model where we have a couple of keys in here, where we have the category, the urgency, and the sentiment, first of all, which are expected to be enums of the following classes that we have just defined. Then we also have a confidence score. We add a description in here. So this is going to be the confidence score of the classification. And we also explain here or put in place that it can only be a value, it can be a float, and it can only be between 0 and 1, meaning that if we put a different value in there, I will show you in a bit, we will also get an error. We also define the key information in here, which is a list of multiple strings. And then finally, we have the suggested action, which is just a string which is a brief suggestion for handling the ticket. So let's see what that looks like if we create an object like this. So we create the ticket classification object. Sorry, make sure we have that in memory as well, and then create the ticket classification object. So we can now have a look at this and we can see all of the information that's in here. But now, like I've said, this uses Pydantic under the hood to validate all of this. So let's say the language model thinks the confidence score needs to be between 1 and 100. Let's see what the model will say. Validation error. Input should be less than or equal to 1. That's what we have specified over here. Now, what happens if we, for example, do something else here where we say general? This is a general inquiry. The model will say general is not an attribute that we can use over here. So I hope by now you kind of like understand high level what we can do with these data models and how we can use it for validation. So the next step is to take these powerful features of Pydantic and combine those with the powerful features of large language models. And that's really where the instructor library is going to come in, because instructor allows us to very easily do this. All right, and then now here in step number 4, we bring everything together in a single function. And now if you look at this, it's almost identical to what we started with, but there are some subtle differences here that make all the difference. And that is first and foremost, since we have now patched the OpenAI client with instructor, we can now put in a response model that accepts a Pydantic data model. So we can now tell OpenAI, tell our system that we want to receive a ticket classification data model from our system, and what the response now will also do. So we still call client.chat.completions, so similar to how you would normally interact with OpenAI, but now instead of getting a chat completion back, we get our response model back. So we get an actual ticket classification object back. And in doing so, we immediately put that validation in place, because we know, because we've just seen, if we try and plug any information into this ticket classification model that is not in line with the specification, it will throw an error. And the cool thing about Pydantic is that the errors are very easy to interpret by humans. It is very good at using natural language to explain what's going on and what the error is. And because of that, we can use that as feedback for the large language model to iterate on that. And that's where this next parameter comes in, max retries. So this is another parameter that is now available because we've patched it with instructor. And what this allows us to do is, if a question comes in, if a query comes in, and OpenAI returns a response, and we cannot load that into the ticket classification object, it will throw an error. It will then feed that error along with all the other context back to the API, and then it will self-correct. And since these errors are in natural language, this tends to work really well. And usually with even little retries or no retries or very little retries, you can make pretty robust systems with this. Now, you do have to keep in mind that multiple queries could increase the cost and the latency, etc. But for now, we're just looking at how to make it really robust. So if we bring all of this together and now run this system using ticket 1, and again, let's quickly have a look at what ticket 1 was. Order the laptop from the store, order number, receive the tablet. Unacceptable. I need the laptop for work urgently. Please resolve immediately. So this is a pretty heavy problem. Urgency seems to be high. Let's have a look at what we have over here. So we can take a look at result 1, and we can now see that this is an actual ticket classification object. And now we also know for sure that it is in line with the information that we've specified. Otherwise, it would have given us an error. So we can also print that by calling the model.dump.json, and we can have a look at all the information that's in here. So the category is order issue, urgency is high, it's angry, very high confidence. Here's some key information. Customer ordered the laptop, but receives the tablet, needs the laptop for work. Customer is considering disputing the charge if not resolved immediately. suggested action, apologize to the customer. You get the idea. Now, this is a very cool classification system. Now, imagine being part of a customer care team, and this is the type of information that already comes your way. And depending on whether it's an order issue, whether it's an angry customer, you might immediately hand over to the manager who, for example, is allowed to give refunds or whatever. And maybe a more junior customer care rep would not be able to handle those type of tickets. It's not authorized to do so. So purely based on that department seniority, you could already start to route these tickets and also store this in your, let's say in your ticketing system or into a separate database where you now all of a sudden, next to just this ticket, also have a lot more metadata and information that you can use to perform analytics. So you can track the categories, you can track the frequency, you can track the sentiment over time. You could create a whole dashboard solely based on these metrics over here. And this is also just the start, because you can infinitely expand the amount of data that you want to extract for this system depending on your use case. That's why if we come back to, let's say, step 1, get clear on your objectives. Why that's so important, because you can see this opens up so many possibilities over here. So let's have a look at result number 2 and run that. So we run the system and here we go. So ticket number 2, let's have a look at what we were dealing with. So having trouble to log into my account, resetting the password, not working. Can you please help me? You've been a loyal customer for years and have several pending orders. It's pretty serious. So let's scroll down what we have. Account access, urgency high, customers frustrated, not angry, but frustrated. High confidence score. And we also have the information here with a suggested action. So that is step 4 of bringing all of this together into a robust system. But now that we have this running, there's one more thing that we can do to improve it. All right, so then the final step 5, now that you understand these principles, is optimizing your prompts and experiment, because there's a lot you can do here. So first of all, we could look at some prompting structures, and this is just an example here where we provide some context, some tasks, we really identify the role, we have some key things to remember over here. So this can also help to provide context, and this will definitely change the outcomes in certain situations. So for example, you could define what defines urgent for your company, what defines angry. You could give examples of the different kind of categories. So that is all, those are all elements that you can put into a system prompt. Now, also, of course, you have the data models itself. So you can experiment with and expand the models to get more or less information from the system and put maybe even more validations into place. And another one that you can experiment with is different models. So in the first example, I use GPT-4o, but simple classification tasks, smaller models are generally also very capable of doing that. And of course, this will decrease the latency and it will also reduce costs, because it's important to consider that these type of intermediate metadata classification types of tasks typically, not always, are part of a larger system as a whole, where you, for example, have various steps throughout the system where you leverage AI. So a next step, for example, in this system could be to already, for certain tickets, already generate a reply. So for example, if the model has identified that it's a general inquiry or simple inquiry, whatever, then throughout your system, you've identified that those are the types of queries that the AI can perfectly answer. But if it's more complex, for example, a complaint about the customer receiving a tablet instead of a laptop, that is probably not something that an AI can handle. So you want to route it to a human. So that's why you can consider experimenting with various different models, where for the generation of the reply, you might use a more sophisticated model. But for the simple classification, you might use something like GPT-5 Turbo or Claude or Anthropic's Haiku and experiment with that to see how the overall system performs. So if we look at this same example using GPT 3.5 Turbo, we can run this over here. Let's wait for it to finish, and then we have the results. So we can still see that in this case, although it's a pretty obvious example, but it's still categorize it as order issue, urgency is high, angry, high confidence score. You can see there is slightly less key information over here. So that's an interesting thing that we can spot. And again, we have account access high, frustrated. So the key variables over here are the same for both the more powerful model and the more simple model. So that's how you create a large language model classification system in 5 steps and really make it production ready. These are the types of techniques and principles that we use in the applications that we build for our clients. All right, and that's it for this video. And by the way, if you're a developer and you want to get started with freelancing, but you struggle to find clients, then you might want to check out the first link in the description. It's a video of me going over how my company can help you to solve that problem. Now, in all transparency, it's a funnel designed to get leads for my company, so please keep that in mind. You don't have to click it, but if you want to get started with freelancing and need a little help with that, you might want to check things out. And now, if you found this video helpful, please leave a like and also consider subscribing. And then if you want to learn more about how we at Datalumina in our company find, build and deploy these generative AI applications, then make sure to check out this video next, where I go over our entire process that we follow right now.